Good morning, good afternoon, everyone. My name is Jesus Centeno, and I will be your host today. Thank you very much for joining us today, and we're very excited to have you attending this joint roundtable webinar between AWS and TIBCO. Today, we have prepared a great lineup for you to talk about computer vision and some of the key aspects and considerations on how to leverage computer vision capabilities in real-life business applications, and some of the most relevant use cases in the industry. So, without further ado, let me introduce today's panel of experts. Starting from left to right, Onkar Dabir. Onkar is an applied science manager at AWS, focusing on industrial application services, such as Lookout for Vision, Lookout for Equipment, and monitoring. Prior to AWS, Onkar led teams in robotics, AI at Amazon, and self-driving cars at Qualcomm. He holds a PhD with 50+ research publications and 20+ patents. Thank you for being here, Onkar.
My pleasure. Looking forward to the discussion.
Thank you. Yeah, next I have Jan Metzer. Jan is a senior specialist solution architect in the manufacturing group at AWS. With over 8 years of experience with AWS, Jan focuses on bringing innovation to large manufacturers in Europe and the rest of the world. Prior to AWS, Jan worked for companies like Motorola and Wayona AG. Thanks for being here, Jan. Next, I have Michael O'Connell. Michael is Chief Analytics Officer at TIBCO Software, helping clients with analytics software applications that drive extreme business value. He has worked extensively in many industries, driving TIBCO products direction to address business problems in financial services, energy, life sciences, consumer goods and retail, and telco, media, and networks. Michael has written more than 50 scientific papers and several software packages on statistical methods. His current book, A Picture is Worth 1,000 Tables, is published by Springer. Michael did his PhD work in statistics at North Carolina State University and is an adjunct professor of statistics in the department. Thanks for being here, Michael.
Thanks, Jesus. Happy to be here.
Thank you. And last but not least, Nelson Petracek. As Chief Technology Officer of TIBCO Software, Nelson helps shape the development of TIBCO's technology platforms and products. With over 20 years of experience, Nelson works to deliver solutions for the digital transformation age, drawing upon his deep knowledge of APIs, cloud, event-driven architectures, blockchain, and analytical applications. A technology evangelist, author, and frequent speaker, Nelson works with customers on the practical use of technologies and architectures, and advises on various information creation and delivery patterns. He holds a Bachelor's of Commerce in Computational Science from the University of Saskatchewan. Hopefully I pronounced it correctly.
You got it.
Okay, perfect. Well, welcome everyone. So let me stop sharing my screen, and we'll get into the meat of today's conversation. So let's start by taking a moment to talk about how computer vision is quickly changing the way most industries are addressing analytics at the edge. Let's talk about requirements and sort of the challenges that you're seeing. So let me open with this question. What are some of the overall mega trends that you are seeing today with computer vision? And Onkar, let me start with you, please.
Sure. So I think definitely cameras are becoming cheaper and are becoming ubiquitous. So I think that part of the story is starting to become true. I think the other thing is deep learning promise is now starting to prove itself in production. So while in earlier, data scientists or computer vision scientists used to hand tune systems, now we're getting more into a data-driven loop, and that's really helping scale applications. I would say in the industrial AI domain, automated inspection is probably the most common application that we see, and AWS Lookout for Vision service is really targeted towards that. And the applications range from inspecting whether there's enough cheese on a pizza to finding defects on printed circuit boards. So there's a really wide range of applications there, covering both end of line, in-line inspection, and even some in-field inspection. In terms of trends, right, I think one thing I definitely see is that customers often do want to start with very small amount of data and then kind of incrementally improve the inspection quality as they collect more data. One commonality I see across customers is that they also tend to be very performance sensitive and cost sensitive. And it's fair to say that at least in the industrial domain, while cloud definitely has its applications and there is traction in the cloud, definitely edge also has a very strong demand. So these are some of the trends that I see.
Excellent. Yeah. Anybody else wants to take a pick?
Sure. Yeah. I mean, just to add on to that, I mean, yeah, we definitely see that as well when we're working with customers. There's a lot more interest these days in taking images and video feeds and actually making sense out of that data. And to the point, it's where do you do that? And so there is that whole discussion around edge and cloud and what you do where. And well, I'm pretty sure you'll ask a lot of questions about that part of it during the rest of this session. But you do see things around even sensor fusion in essence. So we're finding that organizations are looking to take the information they're getting either from images or camera feeds and whatnot, and combine that with other bits and pieces of information. So it could be information from other sensors as well, combining that, and then trying to figure out what that means to them, right? Is that an opportunity? Is that a threat? Is that an issue? What does that mean? And so you're seeing this convergence of, yes, people want to use computer vision and they want to use it for all the reasons I'm sure we'll talk about, but they also want to fuse that with other information from other sensors. And then, yeah, just in general, the hardware is getting cheaper, the processing power is getting bigger, you're able to do more actually on the device itself. And I know AWS has capabilities in that area, of course. And we work with them on different aspects related to that hardware. So yeah, then there's a lot of trends in the industry, but definitely the conversation around computer vision, I would say, has certainly picked up at least in the last, I don't know, I'll give it a time frame, 18 months-ish or so.
And just to add on to a little bit, we're in the world of manufacturing, where we've got expensive and modern types of facilities that are pretty clean, is one big area we see. Inspecting product coming off the lines, but then in a kind of field situation where it's a little bit dirtier, as we might think, in the energy sector, where there's equipment out in remote areas that we want to be able to do remote analysis of images where places are difficult to get to. There's another end of the spectrum there, and so in between that, we've got things like applications in cities and connected vehicles and things like that. So yeah, we see a bunch of applications across a variety of different environments in terms of their cleanliness. It's always a challenge to do image analysis when it's not clean, but we're getting around that more and more.
There's also the trend where we see that not always there are data scientists are requested. So a lot of requests come for services like our Amazon Lookout for Vision service, where you actually not even touching machine learning, even if you're using it. So this is a trend where we see where a lot of customers that cannot always afford a data scientist want to use machine learning and especially computer vision. And that's where all the technology comes together and plays a major role.
Interesting. Yeah. So I think if I hear all of you, there's definitely this trend, like the trends are changing very quickly, right? And I think Nelson mentioned, what was not hot 18 months ago now is one of the hottest topics, right, that we're seeing in the industry. So let me ask you this. So how can one develop solutions that today are deploying one location for one platform in mind, with one tech stack in mind, and be prepared for the future, right, where the future may look completely different and may come with totally different type of requirements in terms of technologies, in terms of architectures. So how do you go about that today?
Yeah, maybe I can start. A very good question, right? And this is something that we see with our customers all the time, right? And there are multiple angles to this question. Let me first target it more from the applied science side. So one natural question you're asking is, if I do have some machine learning models, how do I optimize them for my target, deployment platform? And what we're seeing is that there is definitely a trend where new tools are emerging, which, for example, will allow you to migrate from cloud to edge. The AWS Neo service is an example. The Apache TVM open source project is another example. There isn't a standardization there, but definitely, some of these tools are starting to mature to the extent that they will make these transitions easier. Another, question you asked is, what, if I've deployed to, let's say, one production plant, and I want to now move over and deploy the service to another production plant. And definitely there are challenges there, right? Because there can be so many variations in background, there can be so much variation in lighting. And I think this is where some of the promise of computer vision is starting to really to bear out, because fundamentally under the hood, this gets close to how you train your machine learning models. And it's definitely possible to train these models so that, we are robust to these kind of changes. Or to, create some sort of reactive loops where if performance changes due to a data drift, your system is capable of reacting and sort of recovering performance. So I think definitely that's another science trend that I see, where even the algorithms are now mature so that we can start handling these use cases.
Yeah, it's interesting. I mean, I know sorry, Jesus, from some of the work that we've seen as well through TIBCO Labs and Project AIR is really around trying to, first of all, create the right levels of abstraction, in essence, is what it comes down to. And you mentioned Apache TVM, and that's one aspect of it. But trying to figure out, well, what are the different components that are going to support the processing of image data, streaming video, whatever that is, and how do you, again, create those abstraction layers, kind of create those properly bounded services, if you will, and build them in such a way that they're effectively movable in a sense. And so today you may start with a certain number of services that are deployed all in the cloud, and they're going to be receiving the data feeds from wherever the cameras in this particular context are located. You're going to do your processing there, you're going to make your decisions there, and so on. And then what we're finding is that people are saying, well, in certain circumstances, it makes sense for me to take a subset of those components and move them. And so I may move them to a environment. You'll actually hear the term, edge computing, or you'll hear the term cloudlet, or there's all these different terms, but you almost have like a little mini slice of your data center, if you will, that's closer to the edge now. Mm-hmm. And so now you're doing your processing a bit more locally. And so you want to be able to facilitate that without having to recode everything. And so having the right level of abstraction layers in place, the right level of how you properly decompose your problem into a set of services, all the standard practices that people are using elsewhere also apply to the way in which you build this end-to-end processing pipeline, right, for your computer vision and image data. So I find that a lot of it has to do with good architectural design, using this building block approach, using these kind of VM type approaches, VM in the case of like a TVM, something along those lines, not virtual machine, but these abstraction layers, right, that allow you to take different languages and run them wherever you want to run them. Model-driven approaches, those are all kinds of things that help facilitate the building of these systems that become much more dynamic and flexible so that you can accommodate all these change.
Yeah, just a layer on top of that.
Those are great points.
That's one thing I enjoy about working with AWS is the pluggable sort of building block architecture, where we can plug in components of AWS through a simple Python SDK type call, or in the case of Lookout for Vision, just a service that's already pre-trained. And then the other parts of the TIBCO stack can be plugged into pre-processed data or post-process the results. As you identify issues, go explore them, bring other data to bear on the classification of those and the remediation of them. So that pluggable building block architecture that Nelson mentioned there fits nicely as the TIBCO components and the AWS components can kind of work together.
Yeah, so let me double click on that just for a second, because I think we're getting into a very interesting point here. So we talk about abstraction layers, building block approach, right? But when it comes down to the lack of standardization on, let's say, protocols and data formats, and so how do you prepare for that today, or how do you go about that today, knowing that the number of type of computer vision devices and IoT devices overall is just going to continue to evolve and grow and change? How do you go about that?
Yeah, I think there's two aspects to that. I'll start, and then I'm sure there'll be lots of elements to think about with that particular question. You have to look at it almost in two lines of thought, right? There's the one line of thought that from an industry standpoint or a community standpoint, how do we evolve the standards or specifications that different devices and different interfaces and APIs and things like that are using or exposing? And so that's one element of it. And, you know, that's related to technology, but it's also an industry and community driven initiative as well. And I think that is one thing that has to happen. And, you know, again, with the work that we do and the work that AWS does and kind of gluing those components together, as Michael was talking about, we can help facilitate and help to drive some of the ways in which those interfaces are created and defined, and with the hopes of standardizing and creating these normalized ways of communicating between components. And then the other side, of course, is the technical side. So, you know, how do you deal with all the different protocols and device interfaces and, you know, those kinds of things? I normally will talk about get that abstraction layer as close to that device, if you will, as possible. And so that everything after that abstraction layer really doesn't know specifically what it was that it was talking to, right? It's dealing with an abstracted definition of what the data elements are, or, you know, it doesn't know what the exact camera was or the exact, device was that it was actually working with. And you want to get that abstraction layer as close to that end as you can, so that everything after that is effectively, you're dealing with something that's a little more standardized and normalized. So those are just a couple of things I'll start with.
I think we're coming up with a new term, abstraction at the edge. I like it. Nice. Okay. Let me switch gears a little bit here. You know, I know that we have a lot of expertise in this panel on two industries specifically, manufacturing and oil and gas. So, Jan, Michael, can you give us some concrete examples on image recognition applications that you're seeing today in these fields? Image recognition overall, I think, is one of the primary use cases for computer vision, and I think there's very interesting use cases right in these two industries. So, can you just give us kind of like top of your mind what you're seeing right now?
Yeah, sure. Especially image recognition is used in product quality inside the manufacturing lines. So, for example, think about checking a PCB, so a circuit board, if this is correct or not. With a simple image algorithm, you can check actually if the quality is good or not. So you're detecting the anomalies. Most of the time, you're merging that, as we discussed earlier, with other values. So with an electrical check, for example, if the current is perfect or not. So you're merging all of that, and then you have a perfect outcome of that. And it's easy to integrate that. And this is going in other directions as well, but especially in manufacturing, we see that the quality check is really key and can be easier integrated nowadays.
Yeah, I'll add on to that. The applications I see in manufacturing, oftentimes if there's a physical component that's being produced and being able to quickly scan that, the early work we did with this Amazon service was around manufacturing of solar panels, where you can easily detect a crack in the output. That was a perfect example because we were able to really zero in on that with a high precision, high recall that we got from the service. And it's a fairly high tech product that's produced, but it's also a physical product that you can scan with a photo. We've been looking at other applications in our high tech manufacturing area for the sorts of things that Jan was just talking about. Testing and quality control, and that whole area is in the process of virtual metrology, going virtual on the metrology, and people are really trying to save cost, and it's kind of amazing. Some of the case studies we've got, even some of them on our website, say for example with Hemlock Semiconductor, where if you can take a little bit of cost out from doing a bunch of physical testing, it really adds up. I mean, there's a lot of value to be generated in reducing manual testing and replacing that with either virtual metrology or in some cases image recognition, image analysis like we're talking about today. So there's a lot of kind of, in the ecosystem of silicon, in terms of parts and preparation for some of the wafer manufacturing. In that whole surround of ecosystem, we see a number of interesting examples for image analysis or automated quality inspection. The other area that Jesus mentioned, energy sector, equipment surveillance in remote places is an area that's also expensive and difficult. And being able to fly over, do a drone flyover or something like that. We've got some real interesting cutting edge type examples of analyzing images from drone flyovers in remote locations that are pretty interesting, actually. Yeah, so that's another a big chunk of stuff. So those would be the two big buckets that I'm seeing.
Okay, great. So let me ask kind of like a two-part question here, right? So we've been talking about how quickly the ecosystem is changing, is evolving. I think we touched a little bit on some of the requirements in terms of volume, right? And what volume brings, the complexity that brings to the table, right? And if you think about it, right, like you have like this huge amount of volume coming in from the edge, but yet in order to make decisions, right, many times you have to integrate the data with other sources, and that typically happens more in the cloud side of the house, right? So, how does one blend the needs of the edge and the on-premise in a multi cloud or hybrid cloud application approach? And specifically, how can you leverage then AWS and TIBCO services to accomplish that? So I'll take any volunteers on this question.
You didn't make
I
any
know
of
it's a tough one,
questions.
but
Yeah, I was going to say you didn't make any of these questions light and easy, did you? And short, I guess, is really what it comes down to. I wish I had my whiteboard. I think there's different aspects to this, and this is one of the reasons why we created Project Air out of TIBCO Labs, was to help deal with this idea of creating these pipelines, right? These data pipelines in essence. And so this takes you right from when you're collecting the video, right? You're collecting whatever the images are coming from the cameras, you're collecting them at whatever frames per second you need to, and so on. And then there's that whole pipeline of what you do with that data. And to your point, there is going to be this notion of you may do some of that at the edge, you may not, but inevitably all that information is going to follow some form of a pipeline and end up in a cloud environment. So you're going to end up in AWS so that you can then use some of the AWS services for doing more detailed, let's say, analytics around that, or store it in different ways so that you can access that data in different ways, or combine it with other sets of data. And so this is where we have found that defining, right from what it is that you're trying to achieve at the edge, if you will, if that's where the cameras reside, defining that pipeline is very, very important. And then again, going back to our original discussion around how you create those abstraction layers and how you create the components, you can then dynamically, in essence, figure out where and how you need to deploy those pieces to facilitate the creation of that end-to-end pipeline. And so the other thing to keep in mind is that it's also going to involve different types of processing patterns, I'll call it. So these scenarios tend to be very event-driven, right? Camera detects something, gives you an image, you run your analytics against that, you figure out what it is that you've just detected, and then you want to generate some sort of an action immediately. Right? Otherwise, you're going to end up with all this, what I call decision latency, right? At the time between when you detected a problem and when you took action, you want to shrink that down. And so that pipeline, you need to think about where and how that's going to fit in terms of what you need to do in terms of, again, things like response times. And so it is quite complicated. Things like data quality come into play. How do you eliminate the noise? How much data you're going to push to the cloud? It's not an easy question to answer straight out of the gate without a whiteboard, but those are just some of the things that one needs to think about. And so we've taken, Project Air, combined it with AWS services, and allow you to build that pipeline. It is very flexible that you can run as much of or as little of in the cloud or on the edge, and combine, those two concepts.
And just to add on to that,
okay, excellent.
Part of the strength that TIBCO brings to the table is the data preparation and connections to different source systems, because that's a big part of it. If you're going to deliver some data to an AWS service, being able to connect and then integrate those data sources. Some of them are in moving data, real-time data. Some of them are metadata, data at rest that you want to merge in to provide a clean source system for pushing into the algorithm. And then post-processing that, when you do find an anomaly, there's a whole workflow associated with that. I'm not sure if you want me to talk about that right now, but might as well, I guess, now that I'm on the topic. But oftentimes after you detect, an incident or an anomaly or issue, then you want to cluster up those and figure out, what are the fingerprints associated with one type of anomaly versus another one, and put those together in an incident. Like you might be finding things sequentially and gathering all those up, kind of like a bit like the old Western Electric rule of as you get an exceedance for a certain period of time, you can look at that as an incident versus a single time point anomaly. And then you can figure out what the fingerprints or signatures are around that behavior. And you can go the extra step of identifying the root causes around those anomaly classes. That might involve looking at other data. It might involve looking at log files of the equipment that have generated those data, or it might you might go and pull out some signals out of key phrase extraction type signals, where you're looking at repair logs and finding out when you had a situation like this in the past, what did you do to fix it? You can bring in some of that post-processing data to figure out what's the action plan then to address the causes, what's worked in the past based on the logs. And so, yeah, there's quite an extensive workflow in the front and back of actually doing the detection of the fault, if you will.
Yeah, no, fascinating indeed. And believe it or not, we're almost at the end here. We have about 3 minutes left. I think we'll have to have a part 2 to this conversation for sure. But for now, let me go around the panel and get your closing thoughts, and then we'll wrap it up. So who
maybe
wants
I
to
can
go first?
Yep. So definitely I'm seeing faster adaptation of AI in industrial services. Of course, there are challenges, right? For example, how do you manage your models over a wide range and vast number of edge devices, right? So there are some of these challenges which are there, but I'm very optimistic that we'll overcome those in the near future, and this trend is only going to speed up. So, so just looking forward to engaging with the wider industrial AI community and partners like TIBCO, and help automate monitoring and inspection.
Excellent. Thank you, Ankar. Jan?
Yeah, actually, it was never been easier to use computer vision in manufacturing. So this is really something where customers can start now and try it out. Initially, you don't even need to do the integration portion. You can just test if it's working or not, and then you can do the integration. Also, integration is now easier than years before. So really, we talked about the integration. So just get started now and play around with the technology and just don't wait.
I like it. I like that. Yes, thank you. Michael?
Yeah, look, I just come back to the beginning here. I think this pluggable architecture with this incredible collection of services that AWS offers, specialized services like we're talking about today for anomaly detection on images, but also other services in AWS to sort of facilitate that workflow that I was talking about. And you combine that with the strength that we have at TIBCO for connecting to real-time and at-rest data sources in a comprehensive manner, bringing all the metadata and shared data assets around that to not just identify the anomalies, to then classify them, analyze them, figure out what the best next step is, and put together that workflow from data integration to analytics to post-processing and taking an action. I think that's a really good sweet spot for a combination of our technologies and AWS's technologies for this type of use case.
Excellent. Thank you for that, Michael. And Nelson?
Yeah, I mean, I guess I'm the last one. So just to wrap it up from my perspective, I mean, it is a fascinating space, and to the point that was made, it is relatively easy now to get started, and so it is definitely a technology area that you do want to be aware of. You do want to see where and how it could be applied, because I think you're going to see more of it. And you're also going to see fusion of things like computer vision with augmented reality and all these different ways of interacting with your environment. Creation of digital twins would be another great example that kind of gets or sort of evolves from the examples that we've talked about today. So it's definitely an area that you do want to be aware of, and it is relatively easy to get started. So definitely get started now. The one thing I'll add, and this is probably a topic for the next session, considerations such as privacy and security. We haven't touched on that at all today. It's also a huge topic when it comes to this space. So definitely something to be aware of and to watch.
Excellent. Yeah, you read my mind. Topics for session number 2 for sure. Yes, well, thank you very much. As I move into the last slide here, I'm going to ask you to please turn off your cameras, and let me get into the call to action here. So in case that you want to get it started right away, there's 4 different ways on how you can do so. One would be just get started with Amazon Panorama. So a couple of links there for you to check out at your own pace. The second one, a service that we mentioned many times in today's conversation, Amazon Lookout for Vision. And there is Project Air that was mentioned as well from TIBCO Labs, and TIBCO Data Science capabilities. So a lot around computer vision and image detection for anomaly detection scenarios, as well as preventive maintenance, for example. So there you have it, 4 ways to get started today on this topic. And thank you very much for your time, and see you next time.